Okay, for our second last lesson on perimeter area and volume, we're going to be dealing with capacity. So capacity and volume are often confused. So volume is dealt with in cubic centimeters, cubic meters, cubic kilometers, that sort of thing. Whereas capacity, we talk about liters. So they are fairly closely related, but capacity is measured in liters instead of meters cubed, that sort of thing. So very common for us to think about a drink bottle or something like that, or a swimming pool or a water tank in terms of litres rather than how many cubic metres or cubic centimetres fit inside that container. But obviously, because we can convert from cubic centimetres or cubic metres to either litres, millilitres, kilolitres, it means that we can work out the dimensions, we can work out the volume of a container, and then we can convert that to litres, because litres is pretty much what most people will think of when they think of some sort of container. Even things like fridges are sold based on how many litres they fit in them. So you can see over here on the right hand side, is the basic conversions you've got to remember. And while it is written down the bottom here, I think it'll also go as far as to do this and write a kilolitre is 1,000 litres. So, a metre cubed is a kilolitre, which is 1,000 litres, and a centimetre cubed is 1 millilitre. Obviously, there's the conversions from millilitres to litres to kilolitres to megalitres and gigalitres. Litres are a lot easier to deal with than centimetres than metres, centimetres, millimetres, because everything is either multiplied or divided by 1,000. So there's no weird little changes there. So if we know that 1 centimetre cubed is 1 millilitre and 1 metre cubed is 1 kilolitre, if we look at these basic conversions here, 52 metres cubed, well, that's the same as 52 kilolitres, based on our little box up the top there that's been highlighted yellow. So this is just basically going to be 52 kilolitres. That's what the capacity of that particular container would be. And we've got one here of 43 centimetres squared. Once again, we look up at the highlighted yellow box, and 1 centimetre cubed is 1 millilitre. So that really is just a case of going, well, 43 millilitres, one for every centimetre cubed. The next one down here, we want to move 5.1 metres cubed to litres. So 1 metre cubed is 1,000 litres, so we're just going to multiply that by 1,000. So to do that, we'll move the decimal place 1, 2, 3 times. So we'll end up with 5100 litres, or 5.1 kilolitres. But of course, because it asked in litres, we'll do it that way. And then the last one there is we want 0.7 of a metre cubed into millilitres. I would probably be tempted to move this to litres first. Now, for every metre cubed, you've got 1,000 litres. So I've got to multiply 0.7 by 1,000, so that's going to leave me with 700 litres. And 700 litres, well, I'd need 1,000 times more millilitres than litres. So there we go. Just be very careful, and I'll just circle them. I'll just highlight them here in purple. A megalitre and a millilitre are very easy to confuse. The capital M means a million litres. The little m means 1/1000th of a litre. So just make sure you don't get confused there. Okay, and now we're into questions you'll be more probably used to seeing, you'll get used to seeing through this unit. So we've got to find the capacity in kilolitres of this rainwater tank with a height of 3 and a diameter of 4. So the very first thing I'm going to have to do is work out the volume. And the volume of any cylinder is going to be the area of the base, well, that's pi r squared, times by the height of the object. So that's going to be pi times the radius squared. Well, the radius is going to be 2, because what's given there in the question is the diameter. Half the diameter is the radius, times by 3. So we're going to have, we can just plug that into our calculator, pi times 2 squared times 3, and we've got 37.699 ... And we wanted to find the capacity in kilolitres. Now that's currently in metres cubed, so kilolitres will be the we won't have to change the units at all, change the numbers at all. So it's going to be 37. I think they said, if they said in kilolitres, I might just round to the nearest kilolitre. So rather than 37, I'll round that to 38 kilolitres, and to nearest kilolitre just there so we know what we've done. Moving on to the next question. Actually, I'm going to skip the next question. Just draw a line through that. It's a good question. You can have a crack at it if you want to, but it's not really a capacity question. So I'll just leave that one out for now, because there's a capacity question we did in a previous lesson, or we didn't do. We left in a previous lesson, which I wouldn't mind coming back to. But first, we'll do this swimming pool. So a swimming pool has a length of 6 meters and a width of 5 meters. So that's given just here. And the depth of the pool is 1 meter at one end and 3.5 meters at the other end. And as shown in the diagram, what is the volume of this pool in cubic meters and what is capacity in liters? Now, a lot of people, myself included, may be enticed to break that up into the base into a triangle and a rectangle. But as I keep saying, get used to spotting trapezoids, and that swimming pool is a trapezoidal prism, because this here is a trapezoid. The base there is a trapezoid. We've got the height I'm circling now, and then in blue I'll circle the A and the B, and that 6.5 is of no value to it. We don't really need that. So the volume of any prism is just going to be the area times the height. So we'll first work out what's the area of the base. Well, the area of the base, we'll have to use the trapezium formula, which is height over 2 times A plus B. The height in this case is actually going to be the length of the pool. That's going to be that 6 meters. And our A and our B are the 1 and the 3.5. Okay, so 1 plus 3.5 is 4.5. 4.5 lots of 3 is going to be 13.5. My apologies. There we go. I'll get there eventually. So that's in meters squared. But of course, we then need to find the volume, which is that area times the height. In this case, that's going to be 13.5, and the height is actually going to be the width of the pool in this case, if we're thinking about that side as the base. So that's going to be 5. So 13.5 times by 5 is going to give us 67.5 meters cubed. So therefore our capacity in kiloliters is going to be the same as what it is in meters cubed. So it's going to be 67.5 kiloliters, which is going to be the same in liters. It's going to be 7, and then we're going to multiply by 1,000. So 500 liters. And that gives us our final answer. And I might just put a little something around that so someone looking at this can find the answer rather quickly. Okay, so it's just one more step to do once you've found the volume of the object. Right, we've got internal dimensions of a refrigerator. I'll have a go at that one. We might leave the HSC question for today and maybe have a crack at that at another time, or you guys can have a crack in class. The internal dimensions of a refrigerator, 1.8 meters high by width of 84 centimeters and depth of 60 centimeters. I know that technically fridges aren't rectangular prisms, but we can sort of assume a rectangular prism in this case. So I've got myself my trusty fridge there, and I've got a depth of the fridge. Almost looks as bad as my fridge at home. So if it's a height of 1.8 meters, it's got a width of 84 centimeters, and it's got a depth of 60 centimeters. So the very first thing I'm going to deal with here is I've got centimeters and I've got meters, and I don't want to be dealing like that. I would rather everything to be in the same units. So I'm going to change that 1.8 meters to be 180 centimeters. And now I can find the internal volume. So the volume is just going to be the area of the base of the prism times by the height. Being a rectangular prism, it doesn't really matter what we call the base, but I'm going to call the front door of the fridge the base. And that's just going to be length times width. So I'm actually just going to have 180 times by 84 times by 60. And that's going to give me the volume in centimeters cubed, which is what the question's asked me for. So 180 times 84 times 60. And that's 907,200. centimetres cubed. So the capacity in litres, so we know that 907,200 centimetres cubed is going to be the same in millilitres. So we end up with 907,200 millilitres, but that's not what I've been asked for. I've been asked in litres. Litres is a unit that's 1,000 times smaller, bigger than millilitres. So a number has to get smaller by 1,000. Obviously, we can do a little froggy bounce here and go boingy, 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 and put our decimal place there. 3 jumps for 1,000. And so we're going to end up with 907.2 litres is the capacity of the fridge. So just one thing, obviously there's a actually I really should do that question. That's a good little way of reconstructing it. So this question here, we'll have a crack at him as well. So this time, to get a band 6 in standard mathematics, you need to be able to pull apart some of the stuff you do and do them in reverse order and change it all around. So here we've got a cylindrical water tank with a radius of 9 metres and capacity of 1.26 megalitres. And we want to know what the height of the water tank is. So the first thing I'm going to do is go, well, there's not really a conversion for megalitres, but I do know that 1 megalitre equals 1,000 kilolitres. So therefore, 1.26 megalitres must equal 1,260 kilolitres. And 1,260 kilolitres, well, to get a capacity of 1,260 kilolitres, we'd need a volume of 1,260 metres cubed. All right, so once we know that, we can think, well, let's think about the volume of a cylinder. And we've got the volume is going to be the area of the base, which is pi r squared, times by the height. And now we can just start factoring and use your algebra and start factoring in the things that we know. We already know what the volume is. We just worked that out. That's 1,260. Pi is just a number, so we can deal with that. And it gave us in the question that 9 was the radius of the tank. So we know that this is going to be 9 squared here, and the height is the thing that we don't know. So we can basically just divide this side by, well, 81 pi. You can do it. You can write here 9 squared times pi if you want to, but you might be smart enough to figure out that 9 squared is 81. So if I divide both sides like that, my equation is going to become 1,260 divided by 81 times by pi, and that's going to equal my height. If I plug all that into a calculator, 1,260 over 81 times by pi, and hit equals, I get 4.95 to 2 decimal places, so that's what we're going to get. So we'll go height equals 4.95 metres. Okay, so you just got to be able to do these questions back and forwards. So the final thing I just want to quickly cover is we did look at a lesson a couple of lessons ago on right prisms, and I think down the bottom of this lesson, as we get there, that was in the middle. This example 3, I'd like you to have a go at example 3 now that we've done capacity. So I'm not going to go through that now, but have a go of that and just see if you can work that one out. And I might go through that with you guys on Wednesday when I'm back. In the meantime, obviously for this particular lesson, you've got the text questions there to have a go at from your textbook. Make sure you get a fair way through them. The early ones are pretty basic conversion things that I expect you guys should be able to do in a couple of minutes. All right, have fun with that, and I will see you on Wednesday, if I can figure out how to press stop.